Alright guys, in this section we're going to check out radicals and how to change them to rationals, and back and forth, and then simplifying. Okay, so radicals are things with square roots, cube roots, fourth roots, different things like that. Rationals are fractions, so we're looking at exponents that are fractions. Now here's how this thing transfers around. If they give you a problem that is a fraction exponent, your denominator becomes what's called the index of your radical. So it's the number that goes on the outside. Okay? Your numerator goes in one of two places. It can either go on the inside or on the outside of the entire radical. Okay? So you've got two different places that can go, but your denominator is always the index. So you're basically using this as kind of like a roadmap to convert these things back and forth. Alright, so let's look at these and see if we can make some sense of them. So in this first one, they want you to write this in rational form. So basically, they're giving it to you as a radical. You've got to rewrite it to where you have a fraction exponent. So I've got the fourth root of x cubed. Now, we know that our base is going to be x. That doesn't change. Okay, the number on the outside, our index, is the denominator of our fraction. And then the number that this thing is being raised to becomes my numerator, so the 3 goes there. And so I have the fourth root of x cubed is the same thing as x to the 3/4 power. And there you go. Now in this second one, I can set it up much the same way. So I've got the cube root of 4 squared. So I know 4 is my base. I've got 3, which is the index. That's going to be the denominator. The 2 is my numerator. And I've got 4 to the 2/3 power. And there you go. Okay, so this is one way to look at these problems and rewrite them in rational form. Now, going to radical form is the same thing, it's just reversed. So I've got this rational exponent. My denominator, remember, comes your index. Your index is the number on the outside of the radical. The base goes on the inside. And then your numerator, which is the 5, goes in one of two places. It can become r to the 5th that way, or I could write it as 8th root of r, the whole thing raised to the 5th. All right. Now in the second one, I've got 7 here. That's my base. My 5 becomes the index, and then that is being cubed. Okay. The other option for writing that is the 5th root of 7, with the entire thing being cubed, written like that. Okay. So that's the way to transform back and forth. Now the last part of this is actually simplifying this. So when I simplify this, I've got the cube root of 64y to the 6th. Okay? Now what I want to do is I want to take this entire thing, so here's my base, and I'm going to raise this to some power. Now if you think about it, here's my 3, that's my denominator. My numerator, I could think of it as what's being raised here. Well, that could be the first power, so it's 64 to the 1/3. Now using some of our properties that we learned a few sections back, we can solve this a couple different ways. I can take and distribute this through. So I've got 64 to the 1/3. And then I have y to the 6th to the 1/3. Now continuing on, I'm going to go step by step with this. 64 to the 1/3. You're looking for some number that multiplies itself 3 times to get 64. Or, like it showed here, the cube root. And that's going to be 4. So 64 to the 1/3 is 4. Now here I have a power raised to a power, and that's when I multiply them. So 6 times 1/3 gives you 6/3, or 2, so that gives you 4y squared. All right. Now this last one, I can look at it a couple different ways. I can think of this as a 1/3 power. 1/3 power is the same thing as taking the cube root of 27, p cubed, q to the 12th, all to the 1st, and go through it that way. You know, there's no one way that is, you know, in my opinion, the easiest way to solve these. So find a way that works. Or you could leave it like this and just, like we've said, distribute this through. So 27 to the 1/3 is 3, because 3 times 3 times 3 is 27. P to the 3rd to the 1/3, we're going to multiply those. So 3 times 1/3 is p to the 1st. And then q to the 12th to the 1/3, again, power to a power, you multiply. 12 times 1/3 is the 4th, so that becomes q to the 4th. There's your final answer, and you're done. All right, hopefully that helps out, makes some sense. Give your assignment a try. If you have questions, let me know.